Welcome to this video on adding fractions. Before we can understand how to add fractions, we really need to understand what fractions are telling us. In a fraction, the denominator or the bottom number is telling us how many equal-sized parts the whole has been divided into. So for example, in this first picture, we can see that there are 1, 2, 3, 4, 5, 6 equal-sized parts or slices that this circle has been divided into. So we know that if we want to represent this situation as a fraction, the denominator or the bottom number is going to be 6. Likewise, in this other circle here, we can see that there are 1, 2, 3, 4 equal-sized pieces, so we know that our denominator is going to be 4. Then we have a numerator. So the numerator, or the top number, tells us how many of those pieces have been shaded or selected. So let's say on our first wheel with 6 slices, I have selected or chosen just one of those. So my fraction would be 1 out of 6. Then let's say in our second circle, I have selected or chosen 1, 2, 3 of those pieces. So then my fraction would be 3 out of 4. So there are a lot of rules involving fractions, right? We have rules for addition, subtraction, multiplication, division. And so if you really understand what a fraction is, then it becomes much simpler and easier to keep those rules straight, and they're not going to get mixed up in your head as you go through and learn the rules of fractions. So let's begin. So here I have a pie or a circle that's divided into 3 equal-sized pieces, so I know that my denominator is 3. Likewise over here, I know that I have 2 equal-sized pieces, so that means that I have 2, right? 1, 2. So again, you have 1, 2, 3 pieces here, and you have 1, 2 pieces here. So now what we need to do is we need to select some of those pieces and make up an addition problem so we can practice this. So let's say that over here, I have selected 1, 2 of these pieces, so I have 2/3. And then let's say over here in this other circle, we've selected 1 of those 2 pieces. So our addition problem becomes 2/3 plus 1/2. Okay? So let's just think about what would happen if we tried to add them just straight across. So my question is, would it make sense to say 2 plus 1 over 3 plus 2? Does that make sense? Well, the main thing to realize here is that these slices, right, we'll call them slice 1, slice 2, and slice 3, they're not the same size. Right? Slice 1 and 2 are the same, but slice 3 is not the same. Okay? Moreover, if I do this, this gives me 3 over 5, which would suggest that I would only have 3/5 of one circle. But you can sort of imagine if I were to put all of those pieces into a single pie, you'd actually have more than one whole circle. So this is clearly not the right way to do it. We cannot just add across. Again, visually, when you draw out the circles, it just doesn't make sense. Okay? Well, fine, it doesn't make sense. Well, what does make sense for us if we have 2/3 and 1/2? How can we add those together? And the answer is that what we need to do is we need to have pieces of the pie or slices of the pie that are the same size, okay? So what I can do over here on the left side is I can take each of these 3 slices and I can divide them in half. Okay, so now I have 1, 2, 3, 4, 5, 6 pieces that are exactly the same size. Likewise, on the other circle, I can take each half and I can divide it into 3 pieces. So again, I have 1, 2, 3, 4, 5, 6 slices. Okay, and now hopefully you can see I have all of the same sized pieces. Okay, so mathematically, the way I interpret this process, okay, if we go back to the beginning, right, the way I interpret taking each of the 3 slices and dividing them in 2, the way I interpret that is by multiplying this by 2 over 2. Okay, so again, I'm cutting each of those slices in half. So then, when we multiply fractions, remember we multiply across. 2 times 2 is 4. 2 times 3 is 6. Okay? Likewise, the way I mathematically interpret taking each of these each of these 2 slices and cutting them into thirds, I interpret that mathematically by multiplying this by 3 over 3. So I have 3 times 1 is 3, and I have 3 times 2 is 6. Okay, and the most important thing that should come out of this, even though I did this by hand and it's not perfect, hopefully you can see just by looking at it that the pieces are the same size. So now that the pieces are the same size, it makes sense to count them or add them. So let's count. 1, 2, 3, 4, right? I have 4 pieces. Exactly what we predicted, right? We have 4 pieces and out of a total of 6. Okay, likewise here, I have 1, 2, 3 pieces, right? Again, out of a total of 6. And when I put all that information together, right, if I add them, 4 pieces on one side, 3 pieces on the other, that's clearly 7. Okay, then does it make sense to add 6 plus 6? Is that something that would help us or get us closer to our goal? Okay, and the answer is absolutely not, because both of our pies or circles are still cut into 6 slices. Right? Again, the bottom number, the denominator, is just telling us how many pieces our pie is cut into. They're both still cut into 6 slices, so we just leave 6 on the bottom. So again, if we have 4 slices on one pie, 3 slices on the other, then we have a total of 7 slices, right? And each slice still represents 1/6 of the total. So again, the way we add fractions is we add across in the numerator and we leave the denominator. And again, we cannot add fractions. We cannot do anything unless we have the same denominator. Okay, so when our pieces are divided into different size slices, then we cannot add. We have to get the same denominator or the same size pieces before we can count them or add them. Okay, let's do another example. Here we have something that's divided into thirds. So my denominator is going to be 3. And then I have another pie that's been divided into 5 equal slices. Okay? So let's say, once again, I have 2 of these slices that have been picked out. So that's going to be 2. And then let's say over here I only have 1. So we'll have 1/5. Okay. So again, looking at these slices of pie or pieces, you can tell that they're very much not the same size. So it's not meaningful or helpful to just multiply across. We absolutely cannot do that. It does not get us any closer to our goal. So the first thing we absolutely have to do is we have to make all of the pieces the same size. Okay? So this time, let's think about the numbers 3 and 5. The number 3 is a prime number. It is only divisible by 1 and itself. 5, likewise, is a prime number. It is only divisible by 1 and itself. So the only way to make 3 and 5 become the same number, okay, is to find what's called the least common multiple. Okay, you've also probably heard the least common denominator, or LCD, and that makes sense here because, right, 3 and 5 are both denominators. Okay, so what is the smallest number that is divisible by both 3 and 5? Again, what is the smallest number that is divisible by both 3 and 5? That's my question. Okay, so in other words, I'm going to have some number, I'm going to divide it by 3, and it's going to give me a whole number. Okay, likewise, I take that same number, I divide it by 5, and I still get a whole number. Okay, so since 3 and 5 are both prime, the way we find the least common multiple of those two numbers is simply to multiply them together. 3 times 5 is 15. Okay, so what that means is over here, to transform a 3 into a 15, I have to multiply by 5. In other words, 3 times what number is going to give me 15? Well, it's 3 times 5, which is giving me 15. Likewise, over here, I have to do 5 times some number gives me 15. And the answer is that 5 times 3 gives me 15. Okay? So we can go ahead and multiply these together. We get 10 over 15 and 3 over 15. But let's go back to our pictures, which we've sort of temporarily abandoned, and see if we can visually interpret what we're doing. So since I'm multiplying this whole thing by 5 over 5, what that actually means, and this is going to be a little bit tricky to draw, is that each of my thirds is going to then get divided into 5 equal slices. So let's see if we can do that. So we have 1, 2, 3, 4. That gives me 5 slices. Again, my art is not going to be great. It's not going to be perfect. Okay? 1, 2, 3, 4. 5 slices. 1, 2, 3, 4, 5 slices. Okay? So that's what it means when I multiply by 5 over 5. I'm cutting each of the thirds into 5 sections. And again, you know, it's not perfect the way I drew it because I did it by hand, but you can see now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 sections. And if you use your imagination, we can pretend that they're more or less the same size. Okay? All right, so what do we mean over here when we multiply by 3 over 3? What are we doing? Well, what we're doing over here is we're taking each of these 5 segments, right, and we're cutting them into 3 equal sections. This is a little bit easier to do. Oops. Okay, so this is what it means here. Okay, so again, we can count, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so again, aside from the fact that I freehanded both of these diagrams, right, if you use your imagination and pretend that the computer did it and it was perfect, you can see that all the slices are the same size. So now all we have to do is go back and count the number of slices, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 shaded slices. And lo and behold, that's exactly what we got when we multiplied 5 by 2. So it makes sense. Our picture matches with our math. Right over here, we only have 1, 2, 3 shaded slices. So again, that's 1 times 3 or 3. So again, our picture matches up. So last but not least, right, we actually want to add these. So we have to add 10 fifteenths and 3 fifteenths, and that gives us 13 over 15. Okay? If I were to visually represent that in a single pie, right, you could see that that would be shading 1, 2, 3 more over here, right? And 13 fifteenths visually makes sense because it's almost all of one circle. Okay? So again, adding fractions, you have to have the same denominator because you have to have equal size slices. It does not make sense if your pies are cut into different slices to add the numerators together. So again, the only way we can add fractions is if the denominator, the bottom number, is the same.